Hello viewers, welcome back. In this tutorial we are going to sketch the cluster algorithm. So let's start. Import numpy as np, import matplotlib dot pyplot spt import matplotlib dot style as st style, then st dot use ggplot out there. Now I will be using this data set. So let's see, plot this data. Plot scatter data set plot dot show. So plot dot show. So this is the data set out there, and I will be classifying this data into two groups. So let's go. We will be using class here. So class, write kmean out there. The name of the class is kmean. Def double underscore, then init first bracket, write self. This is not a parameter actually, this is for class. Now class parameter, now give k equal to 2, since I will be classifying into two groups. By default I am giving here 2. Then tolerance level equal to 0.001. I will be explaining it later. Then max iteration equal to, let's give 150. Okay, then self dot k should be k, then self dot tol equal to tol, self dot max iteration equal to max iteration. Now define fit function, self, then send data set out there. Now I will be writing self dot, let's say, centroids out there, send list of centroids out there. Now for I in range of self dot k, write self dot centroids I equal data I. So basically what I am doing, initially I am taking any 2 points as the center out there. Now come out of the loop. Now for I in range, say max iteration, self dot max iteration. Now I have to write self dot classification classifications, again give a empty list out there. So for I in right range of self dot k, so self dot classifications I equal to a empty array. Again come out of the loop. So I am making a empty array for each classes. Now I have to feed the data out there. So for point in data, I have to find the distance of each point from the centroids out there. So write this numpy dot len alg dot norm, then subtract self then subtract point with self dot centroids, then of class 1 for I in self dot centroids. So I will be making an array out there of distances. So distances CS. So this will calculate the distance of each point from each centroids. So now I have to find the classification out there. So classification, not classifications, equal to distances dot index mean of distances. So if I write out there, let's say distances is of 9 and let's say 6. The distances array will be like this one. So if I mean this, I will have 6. The index of 6 will be 0 and 1, so 1. So classification will have a value of 1. Now I have to put this point of class 1. Okay, so self dot classifications of type classification equal to dot append. I have to put the point out there. So I have classified all the points out there in the centroids according to the centroids. Now I want to now write centroids what should I, previous centroid equal to dict of centroids. Okay, self dot centroids. I have to give the dict out there to preserve the value. Okay, since self dot centroids is always changing. So now write another loop for let's see out there classified. So points are out there. Now I have to find the, what should I do? Let's check. So now I will be finding the center of the classified data. So let's do so. Okay, let me explain this one. So I have let's say I have taken this point and this point and grouped this data on the basis of these 2 points. Okay, so now I have to find the center of this group. Now go for it, write a loop for I in centroids, I in self dot classifications numpy dot average the average of self dot classifications of I on the basis of x is equal to 0, which means on the basis of column I will be finding the averages. So the new centroids should be this one. So self dot centroids will be of this one. So this will be the new centroids out there. Now let's say I have optimized equal to true. So that means I have found the center of each group. So now write a loop for I in self dot centroids. Now previous centroid equal to original. So original centroid equal to previous centroid I, and let's say present centroid equal to self dot centroids I. So these are the 2 centroids. Now I will be comparing if ABS sum original centroid minus the present centroid so I will be actually finding the change of the centroids of the new centroids with the previous centroids so let's do so. Right, so out there I have given a tolerance value of 0.001. So if the change is greater than 0, then I have to write that the optimization is not occurred. So optimization will be turned into false. So greater than tol self dot tol, then optimized equal will be false. Okay, now okay, so let's check the bracket out there. For sum out there I have obtained, okay, there required another bracket, so this one out there, and for this one I'll be having, okay, yeah, then for abs I have to give another bracket out there. So yeah, that should be fine. Okay, now I have to go out of this loop, that is this loop out there, yeah, this loop out there I will be using a condition. So right out there, if optimized, then I have break the loop. Okay, so I have completed the feed function here. In the next tutorial I will continue from here. I will write the predict function of the class and finish the cluster algorithm out there. See you then. Thank you.